Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray, and in this video we'll be looking at how to graph the reciprocal of a function. So let's get started. So the transformations that we need to do when we graph the reciprocal of a functions are a few. Let's look at them. So if y is equal to f of x is a function and we want to graph y is equal to 1 upon f of x, then these are the points that we need to remember. First, the zeros of y is equal to f of x will be the vertical asymptotes of y is equal to 1 upon f of x. Why this is because wherever f of x is 0, 1 upon f of x will not be defined, and that's why those points become vertical asymptotes. Second point, the vertical asymptotes become of y is equal to f of x become the zeros of y is equal to 1 upon f of x. Of course, if wherever this is not defined, the denominator is equal to 0, that means on taking the reciprocal of that, y will be equal to 0. That's why the vertical asymptotes of this function become the zeros of the reciprocal function. Third point, the local maxima of y is equal to f of x will be the local minima of y is equal to 1 upon f of x. Wherever f of x is maximum in the neighborhood, it would mean that 1 upon f of x will be the minimum, because wherever this is maximum, the denominator here is maximum, that means this becomes a local minimum. Fourth point, the local minimum of y is equal to f of x will be the local maximum of y is equal to 1 upon f of x. Of course, wherever f of x is minimum, 1 upon f of x will be maximum, because if this is minimum, denominator is minimum, that means this value will be maximum. Fifth point, if f of x is positive, then 1 upon f of x is also positive. If f of x is negative, then 1 upon f of x is also negative. Sixth point is, if f of x tends to 0, where f of x tends to 0, 1 upon f of x will tend to plus minus infinity. As the denominator is tending towards 0, the value of y will tend to either infinity or minus infinity depending upon the sign. And wherever f of x tends to infinity, 1 upon plus minus infinity, 1 upon f of x will tend to 0. So these are the points that we need to remember while graphing the reciprocal of a function. Let's take an example to see how we can graph the reciprocal of a function. Okay, so first example, make the graph transformation from y is equal to x minus 2 to y is equal to 1 upon x minus 2. So now, remember the points. First we see that 2 is a 0 of this function. So x is equal to 2 will become a vertical asymptote for this function. Let's make the graph of y is equal to x minus 2 first. It will be a straight line like this. This is y is equal to x minus 2. Now for this graph, x is equal to 2 will become a vertical asymptote. So we make a dotted line for that. X is equal to 2. Okay, now we see that whenever x tends towards 2 from the right side, so towards 2 from the right side, it is greater than 2, just a little bit greater than 2. So a bigger value minus 2 means that this is positive, but as it is very close to 2, this tends towards 0. 1 upon 0 will tend to infinity, but with the positive sign. So the graph tends towards infinity. And as x tends towards plus infinity, infinity minus 2 will be tending towards infinity. 1 upon infinity will tend towards 0. So the graph will go like this in this interval. When x is less than 2 and tending towards 2, that value minus 2 will be a negative value but very close to 0. 1 upon 0 with the negative sign will tend towards minus infinity. When x is tending towards minus infinity minus 2 will be tending towards minus infinity. 1 upon minus infinity will tend towards 0 minus. So the graph will be going like this. This will be the graph of the reciprocal function here. Let's look at the second example. Y is equal to minus x square to y is equal to minus 1 upon x square. The graph of minus x square will be a parabola facing downwards like this. So y is 0 or negative always. That means the reciprocal function will also be either equal to 0 or negative always. Now wherever y is 0, wherever this function is 0, this will be, for this function it will be the vertical asymptote. So in this case the y-axis is the vertical asymptote for the function. Now let's look at the extremes and in the neighborhood of the asymptote. As x tends towards infinity, y will tend towards 0 minus, as it will be having a negative sign, so 0 minus. As x tends towards 0, y will be tending towards minus infinity, so the graph will be going like this. Let me make the previous graph dotted so that we know, we do not get confused with it. Now as x tends towards minus infinity, this will tend towards infinity. Minus 1 upon infinity will tend towards 0 from the negative side. As x tends towards 0 from the left side, negative number square will be positive, but it will be very close to 0. So 1 upon 0 will tend towards infinity. Minus sign means this will tend towards minus infinity. So the graph will look like this. These two curves together make the graph of this function. Okay, let's look at another example. This is the graph of y is equal to f of x, and we want to make the graph of the reciprocal function. So let's start. First we see that 0 and 3 are the zeros of this function. So these become the vertical asymptotes of the reciprocal of the function. This is one asymptote and this is one asymptote. Then we notice that the vertex of the parabola is a point of local minimum. So this will become the point of local maximum for the reciprocal of the function. So at x is equal to 3 by 2, f of x is equal to minus 2. So the inverse of this will be 1 upon minus 2, that is minus 1 by 2. So 3 by 2 comma minus 1 by 2 becomes the point of local maximum for the reciprocal function. Now we look at the different intervals. One is this interval, second interval and third interval. Let's start with this last interval. So as x tends towards infinity, f of x tends towards plus infinity. That means 1 upon f of x will tend towards 0. As x tends towards 3, f of x tends towards 0. That means 1 upon f of x will tend towards infinity. So the graph will go like this. In this interval, in the middle interval, as x tends towards 3 from the left side, f of x tends towards 0 but with a negative sign. So 1 upon f of x will tend towards minus infinity. So it will go like this. As x tends towards 0 from the right side, f of x tends towards 0 with a negative sign. So 1 upon f of x will also tend towards minus infinity on this side as well. So the graph goes like this. This is the local maximum. So the graph goes like this. In the third interval, here less than 0, as x tends towards 0 from the left side, f of x tends towards 0 but with the positive sign. 1 upon f of x will tend towards infinity. As x tends towards minus infinity, f of x tends towards infinity. So 1 upon f of x will tend towards 0. So the graph will look like this. Let's make the starting graph dotted. Now the solid line graph gives us the graph of the reciprocal function. So guys, we looked at how to graph the reciprocal of a function. I hope you liked the video. If you did, don't forget to hit the like button and subscribe to our channel, and we'll keep the videos coming, and give us a big thumbs up in the comment section as well.